Hey, what's up? It's Teal Gamer, and welcome to my stream on why some people will never be able to do math. Before getting into this, I'm going to wait for a couple of people to get in because they said they wanted to watch. I did basically make this video for somebody that wanted to talk to me or, would watch a video I made, but I said I'll just live stream it instead. So this whole live stream is specific to somebody. And so before getting into it, I'm gonna lay a few things out. Then I'm gonna go over an in-depth explanation and detail on exactly what the issue is. And this isn't to be negative. This is just stating facts that nobody wants to talk about. And so I'll go over. I'll start by explaining my own life story, not life story, but my own issues with the subject matter and how I actually came out with this information and discovered something problematic within the mathematical system itself. So wait till a couple people get in. I'm gonna drink some coffee here and hang tight. I'll just look at the camera dumb. How's it going, viewer? Oh, it's just regular coffee. It's just I don't know. It's a regular coffee with like flavored cream in it. I don't drink. I drink way too much coffee. I'm gonna like die of a fucking heart attack and shit. Somebody actually I made comments underneath some videos, and I was looking at this and I was like, this is ridiculous. And so you hear a lot of false information and false statements, and there's just some crap in mathematics that just don't apply. And I'm going to cover all that stuff when I go over this, if you're interested. I know you didn't request me to make this video, but somebody else did. So I did let them know I was on. I just want to see if they show up. They're probably not going to show up. It's one of these humor things. People can, if he does show up, then I feel like an ass for saying, oh, he's trolling. That's not it. Oh, man. Yeah, this is going to be kind of like a weird video because it goes against, like, this is basically me against the mathematical community. I mean, what else is new about this channel? What else is new? But you have to step back and actually take a look at what I'm saying, because this isn't really to shit on anything. It's I've literally pinpointed a problem within the system itself that applies to everybody who can't do math. And so you find a lot of weird things involved in this, but because of how I look at things, it helps me to, pick this apart and shit. So if you or somebody you know has an issue with math. Okay, well, like I said, I made this video specific to somebody replying, because a lot of people ask me, it's like, do you really get reply? Yes, I have people that talk to me because I leave comments under other videos. So when other people wonder how I get emails, I kind of say the word email, but they don't really email me. What it is I leave messages under other YouTube videos, and that's how people contact me. They basically leave replies off my replies. So I really needed to be clear about that, because I feel like a shitbag. It's like, people are messaging. Nobody's emailing me. Nobody has my email address. Yeah, okay, yeah. Like I said, I mean, this isn't to shit on things. This is just to state base facts. So when I start discussing this stuff, it'll actually click in, because I will be talking about things nobody talks about. There's not mention of it, and it'll I don't want to say it's not going to solve any problems. You're not going to be able to know how to do math with what I'm talking about. It's just going to help you identify where the problem is and what is actually causing it. And I'll be going over some really screwed up descriptions. Now, some of this stuff is going to get really intricate, but if you bear with it, it'll make perfect sense. And so I figured, instead of attacking video games, I'll leave that shit for a while, because everybody knows that friggin' thing is all done. I might as well just take my information to pick things apart and to make an actual useful video out of it, because I mean, I just fucking ramble sometimes. But But let me just give it. Let me give this person one more, 1 or 2 more minutes. If not, they can just watch the video afterwards. So give it 1 more minute. And actually, there was another person underneath that video. So all right. So I'm gonna begin in like 30 seconds. Toot toot. All right. What's funny about me is that like people can look at me as a complete jackass, and I am. I'm a jackass. There's no worry. There's no two ways about that. The thing here with me is if you actually read through all the bullshit of what people say, people taking my videos and whatever else, and if you actually step back and take everything apart that I'm talking about in any of my videos, you will see that everything I say is correct. And it's not to be an ass, it's just this is what this channel does. It rips shit apart. Sometimes I have to be rude, sometimes I don't. Okay, so I believe that person is actually here now. Okay, so what I'm going to do, before getting into this video, I'm going to explain my own issues with this, because contrary to what people may think, I cannot be taught math at all, period. I am impossible to teach. And this is where I started realizing that it's not me that can't be taught. There's a problem within the system. So let me begin by getting into where I started this from. Okay, as you all know, if you don't know, I'm a professional magician. And my agent was an honors physics 2 student and graduated the University of Lowell, I believe it was. I think that's where we went to school, in honors physics 2. So he actually was my math tutor. And a lot of the stuff that I went to him about, I just didn't get. So as of this date right now, if you cannot do math, you're in the same boat as half of this country, and I'll explain why. So what I started doing was I started looking at why I couldn't do anything. Because if you start listening to teachers, you start listening to these people doing motivational speeches and everything else. No. So the first thing I need to get out of the way is this is not going to help you do math. That there's no way this video is going to help you do math, and by the end of it, you'll understand why. The second thing here is it's going to help you identify where the problem is. So if you need to ask for help, you know exactly what has to be done in order to help you. And this one thing I discovered, it's the same problem with everybody. So you'll have people say, "Oh, it's different. Every people learning." No, this problem is the same for everybody. It may just be on a different level, but the problem is identical for everybody. So it just depends where along the lines you are, but the problem is still the same regardless. So I have gone through tutor after tutor after tutor after tutor, and what wound up happening was I started having to learn tricks to get through math. Now it's weird too, because you'll hear people say they're bad at math, or they're worse in math. And if you understand my channel and you know the difference between when I say I'm bad at something or something's bad, it's bad. So I'm not just throwing myself as a comparison, because the average person is just saying they're bad but don't know why. I can actually tell you I am horrible at math, I suck at it, and I am unteachable. I have literally had tutors quit on me. And one of the problems is when I started talking to them, nobody in the academic community wants to hear where the issue is, which is why you can't solve the problem of why you can't learn. So that's basically where I am. I'm speaking from experience. I'm speaking from going through very bad frustration. I've gone through, self-taught stuff, looking at videos, and I'm just listening to this. I'm like, that is so not true. And it's just funny how people will say certain things that are just not true. So the first thing I'm going to get out of the way are false statements. Okay, so if you look at this as a whole, all right, what I have on the screen I'm going to break down, because I have another section called basic facts, or I don't know what it is yet. I labeled it. I fucking can't even remember what the picture is. But anyway, I'm going to go through these one at a time, and I'm going to break them down and explain why these are false statements, because I don't like to say stuff without explaining it. So, okay, first of all, number one, math is easy and hard. Now, there's no such thing as math being easy or hard. Math is just there. It's not easy or hard. It's neither. What that means is people will look at it because they don't understand it, because they don't know where the problem is. Math is not easy and it's not hard. Second, you can get good or better. Also a false statement, because once you reach the problem barrier where I've picked out, you'll understand why it's impossible to get good or better. Anybody who says that they get good or better didn't really get good or better. It's not, no. Okay, another false statement. Practice or practice more. Also false. And this is, what's weird is, this goes against, everything I'm talking about goes against everything you will hear a teacher, professor, any motivational speaker, and they'll, oh, this is, you're just being negative. No, these are the facts about the problem. The fourth one here, this is the ball breaker. Learn the rules. That is partly why there's a problem with this math, but these are just false statements. Learn the rules. You can learn all the rules you want. It's not going to correct the problem. 5, have the right teacher. You can have the best tutor in the world. Once you hit this barrier, it is impossible for anybody to teach you. That is why I am not teachable. And that leads into the statements of, well, you just don't want to learn. You're not motivated. Those statements need to fucking be removed from like teaching in general. Okay, just because you don't want to learn, that doesn't mean, just because you don't get the concepts, because the teachers don't get the concepts of where the problem is, because nobody wants to listen to it, doesn't mean you don't want to learn. And that just frustrates everybody every more, and it isolates you. So these are all run-on problems that are basic foundations of where these problems arise. Next, these are the base problems with math. Okay, first of all, the word maths, that thing pisses me off. Now, this is a pet peeve of mine, because I'm a stickler for this. And I'll explain why I cannot stand that freaking word. That word, okay, it's from Europe or something like that. It's a European word. It's like we here in America spell color C-O-L-O-R. In, the UK, they spell it C-O-L-O-U-R, which is actually the correct spelling of it if you look at it, because we've adopted our language from theirs, or something like that. Anyway, that's not the point. The point is, the word maths pisses me off. And apparently it's supposed to be an abbreviation at the S of mathematics. But here's why I have an issue with this. Now, this isn't going to do anything. This is just a pet peeve of mine that pisses me off. So if you hear people say this, it fucks with you. Okay, there is only one math. There isn't multiple maths. Just like you don't say, I'm going to go teach histories. You say, I'm teaching history, because history is one thing divided up into multiple sections. But it's still history. It's history as itself, because anything in the past is history. You don't say, I'm going to go histories. Another thing you don't say is, I'm going to go, I should have wrote this down. I had a private example for this. But the word maths pisses me off for that reason. It is math. There's no S at the end of that. If you want to go use that shit, go to fucking England. Sorry, that's a pet peeve of mine. But again, the wording on this, it's like, you don't say I'm going to go teach histories. That's not a fucking thing. All right, so now, second base problem. Asking for help is pointless. The reason why asking for help is pointless, despite what anybody says, is because of the base problem barrier. I call this the base problem barrier, I guess, is what, for lack of a better word. There's a specific barrier that once you hit, there is no amount of help you can do. And the reason why asking for help is pointless is because, number one, when somebody's having a problem, they don't understand where the exact problem is, or if they do, they can't word it right. And the second part of this, no one wants to see the problem, is why asking for help is pointless. So let me read this. Hold on here. I got somebody writing something in. Yeah, but they're a foreign company, so that's not even relevant. I'm just talking about in general. It may be the proper terminology for it, but the problem that's not relevant. And again, the word maths also apply to other things in here. Okay, so back to what I was saying, asking for help is pointless. Not for the fact that asking for help is not pointless. What I'm saying is specifically in math, if you are having an actual problem, like the one I'm going to describe, there is no possible way you can formulate it unless you know exactly what is going on. And the help will not be given to you because nobody in the academic community, when it comes to math, wants to hear it. I have literally tried putting this out in drawing board, but they just, nope, ignore that, ignore it. Nobody wants to hear it. And so, unless they actually take the time to listen to everything that you are saying, there is no possible help for this at all. Okay, and the reason why nobody wants to see the problem is because there's no room for debate. This isn't something like you can say, oh, I think it's sunny out, I think it's cool out, this weather's cool. There's no debate on this because nobody wants to leave the room for debate. But again, if you listen to everything I'm going to tell you in this, you will see why there actually is a complete debate with this. And the final thing is the wording. And I have top and bottom here, which I'm going to go over an example with, that I actually got into an argument with my tutor with it. I have literally gotten into arguments with a tutor with this. Multiple tutors. I've literally had tutors get up and walk out because I brought this to their attention. And they didn't want to hear it. I was literally in heated arguments with them. Surprise, surprise. So, but here is the thing, and this was after they were supposed to be teaching me. If a teacher is going to teach you, and this is one of the things I had brought up I brought this up to several tutors. If you are a student and you're supposed to be learning, and you are having a problem, a teacher who is teaching the subject should be able to recognize where your problem is by what you're describing. And then by, hitting that specific point in time where you're having a problem, figure out where it went wrong, undo the problem, and then be able to correct you to continue going. That doesn't work with math because math is an absolute, which is another problem. So let me get into a little bit of detail here. So for now, before I go on any further, do all of you understand so far what I'm talking about? Because like I said, these are key factors that it plays a part in everything I'm talking about. I just don't want to lose anybody. Because this is going to get very intricate. By the way, I've also come up with a few base formulas that show when like math people try to argue with me, I come out with things that they can't argue against, and I show where the flaws are. Math has massive flaws in it, and it is I feel like I'm Einstein talking to professors. It's like the old statement of something's wrong with math. Everybody's saying no, there isn't, and there is, and Einstein proved it. This is literally how I feel. I know there's a freaking problem with this, and it's like, how do you not understand this? And so I have literally picked out flaws in the math, and when you hear this, you're going to go, what the frick is this about? Okay, you don't have to be convinced. I'm just telling you where these points are because they go into the actual issue itself on where the problem is, on why some people just will never be able to do math. They just can't do it. So the first thing here is you don't have a problem with math. No person does. So how can it possibly be that some people do it, some people just are like, what the frick is going on? This is where the split off comes from. Now, I'm going to be straightforward and say this next thing is going to be a little confusing, but bear with me and I'll break it down and explain it. The people who follow the math rules are the ones who can't do math. The people not following math rules that math itself lays out and says this is how this has to be done are the ones who do math. The people that are going through and doing this are literally doing something math says cannot be done. And that is where the branch off comes from. The people who follow rules can't do math because math tells you it can't be done. Math in itself is set up so you cannot do it. It's impossible. And this is why you hear all these things like math follows no logic or anything. No. If not you in general, I'm just saying in general, if the mathematics, the basic fundamentals of math, and I'm talking addition through addition through division, there are basic systems in place that is the foundation that allows mathematics in itself to work. That foundation stops after division. Let me explain. People who accept 1 plus 1 is 2 is pretty much everybody. People who are taught, now that principle of 1 plus 1 equals 2 sets the foundation for how mathematics in itself works when it comes to addition. If you have 1 and then another 1, those are just numbers. Without an actual symbol in there telling you what to do with those numbers, it'll never be 2. Once you put an addition symbol in there, 1 plus 1 equals 2. The addition symbol in itself, once put into this equation, turns it into an actual math problem, which says, not only does math say, the basics of math say, an addition symbol must be put there in order for you to have 1 plus 1. Okay? Forget about the answer. But in order to add together two numbers, having two numbers together is not the same thing as adding a number with a number. The addition symbol is what makes the math problem. Now, once you're told 1 plus 1 is 2, that does two things. One, it tells you that you add things together. But two, there's an underlying thing where the structure of it is now implanted in your brain that you cannot get 2 out of 1 and 1 unless the addition symbol is present, period. That locks that base principle in, and that is the fundamental rule for mathematics. The problem starts stemming from after division, because you start getting into these parentheses, you start getting into word problems, you start getting into what they call exceptions. There's no such thing as an exception in math. I don't care what anybody says. And here's the thing with this. I will literally debate these points with professors. I'll friggin' debate this with, Degrassi. I don't give a shit. Because I will never agree with the entire mathematics community simply because the foundation and the base principles and the rules of mathematics itself prevent anything from division on being done. It cannot be done because math says it can't be done. So this is why people start saying, well, you have to learn the rules. And then they start removing the rules that allow this mathematic principle for you to get it done. So, and this is an example. If you have 1 plus 1 and you're told that roots the foundation of, in your brain, you cannot add numbers together without an addition symbol. You just can't. Math says you must have an addition symbol in order to add. It has to be present. The other thing is math is an absolute, meaning 1 plus 1 will equal 2. That is a definite 100%. You cannot change the answer. What happens here is in these upper problems, the plus symbol, this is an example, but I'm going to go into a lot more detail with this. But the base foundation of what I'm talking about is in these upper symbols. These upper equations, problems, algebra, things like that. These symbols that allow you to do the math have been removed. You are then told they're turned into some word problem. Now, this is where people who follow the rules can't do math. The people who follow the rules are actually applying. You cannot, under any circumstance, because math is an absolute, add a number together without an addition symbol. If the addition symbol has been removed from the problem, regardless of the reason, you cannot do the problem. The problem is unsolvable, no matter what anybody tells you. And the reason why the problem is unsolvable is because not you, not the teacher, not somebody saying it can be done. The addition symbol in the structure and foundation of math says it 100% has to be present or you cannot add numbers. Once you get that principle down, you cannot unchange the principle. It doesn't work because you're told you have to have that addition symbol. In the upper problems, the addition symbol has been removed. Now you get stuck because now you are literally trying to solve a problem with a formula that no longer can be used, despite the formula is what makes that problem usable. So what you have here is a conundrum. I like that word, conundrum. If you have the basics of math saying the addition has to be, the symbol has to be present, but somebody's telling you the problem can be done without the symbol, what the fuck is going on here? Because if the math says the symbol must be present, then that means the problem can't be done. If you are going to say that the problem can be done without the symbol, then you just shot the entire basic principle of mathematics out the fucking window. You are literally saying 1 plus 1 can equal 2 even without the addition symbol, despite mathematics tells you it has to be. So what you have is people are fucking with the formulas after they're telling you what the formulas are. And that becomes a problem because the people who follow rules will never, ever, ever get that concept out of their head. Once you have it cemented in your brain that you have to have the addition symbol, there is no amount of teaching, help, discussion, debate, anything that will ever tell you you can do that problem without an addition symbol. You can sit and look at it. You can sit and get frustrated with it. You can even tell the teacher, you just said that this is how this works. Math itself tells you how this works. But now you're saying, no, I don't have to listen to that. Okay, if I don't have to listen to that, then what the fuck are you telling me 1 plus 1 is 2 for? Well, you need that because the math can't work without it. What the fuck is going on? So the point that I'm making is, with this particular aspect, is that this is why some people just will never be able to do it. Because they cannot they've had the rule that makes math work cemented in their brain, and that it's been ripped out and said, oh, it can work without it. No, it can't work without it, because if you're going to say it can work without it, then you just literally said that all of basic mathematics before division don't even work. There's no code, there's no problem. Well, you got to put a division symbol. No, if I have to put a division symbol here or an addition symbol here, you cannot tell me this problem can be done without it. So what you have is a contradiction. And despite what anybody wants to tell you, that contradiction cancels, each side will cancel the other out. Meaning, if you have to have an addition symbol, the problem can't be done. If you're going to say the problem can be done, that means you don't have to have an addition symbol. But yet, basic mathematics tell you it has to. So this isn't about the teacher. This isn't about you. This isn't about this is about mathematics. Mathematics in itself requires it. So this isn't even an argument that a teacher or professor can theorize on. This is what mathematics tells you. And for people to say it can be done are not following the base principle, because if they do, they would realize what they're saying is not true. So I'm going to let this go for a second before I get into anything else. But I just want people to absorb this to see if you understand exactly what I'm talking about. So it would be like telling you can sweep a floor without a broom. No, it's like telling you need a broom to sweep a floor, and then telling you sweep the floor without the broom. What? And then telling you, well, there's an exception in this room. What? No. It's completely inconsistent. It completely goes against its own principles, and people are just like, oh, just go with it. No. Well, no, I have to get into it. Yeah, it's not, like I said, this is a complex issue. The reason why I did that is for the next couple of parts on this. Because there's more to it than this. There's way more to it than this. Let me get into the debate about let me get into the debate with the, where is it? The wording with top and bottom. Okay, this is another problem inside math, because you're being told one thing, and then you're having words being manipulated inside the problems to completely come out with different context than originally. But again, the same issue applies where you're told this is how things work, and then you're told no, and then it's assumed for you to know something. So you could have left that message in there, by the way. All right, so let me get into, and I'm specifically focusing on the word top and bottom. This is an actual argument I got into with my tutor, and I've gotten into this with multiple tutors. This has to do with fractions. In mathematics, you are told top is top and bottom is bottom. So if you have a fraction, you have a top number and a bottom number, okay? Now, that sets for you to understand top part of the equation, bottom part of the equation. The top and bottom go throughout, various issues. No matter where you do, if you see a number on top, see a number on bottom, that's top, bottom. Okay. This is what I got into an actual, this caused an argument to the point I left. I just left because I got so sick and tired of listening to these contradictions. I got fed up with it. He gave me a problem, and then he put some numbers on the top bottom because we were going over some formula. And then he tells me, this is the exact sentence he tells me, remove the troublesome numbers from around the problem. Okay? So he was watching me do it, and then I scratched out, what he told me to do. And then he goes, well, how did you arrive at this answer? I says, I did exactly what you told me. I removed the troublesome numbers from around, because he was telling me to get these numbers from around out of the problem so you can deal with specific numbers to set up the equation. The problem is in the wording he used. And even after arguing this point with him, he still refused to understand why what he said was a problem. And like I said, it caused us to have an argument to the point I just walked out. And I've had this same argument with every single math tutor. Every single math tutor. And there is no math tutor on the face of this friggin' planet that is going to tell me this. I don't care. So my point, I know this sounds weird, but what happened was the word around, somehow, he just completely obliterated the word top and bottom. And literally, it's like if you were looking down at it, it was around the problem. This included top and bottom. And I says, no. Because we were talking about fractions at the time, mind you. So I says, no. You said around. That means side. You literally, because what happened is they left, you're basically in so many ways having it drilled into your head when you're dealing with fractions. Top is top and bottom is bottom. The sides, top does not apply around. And the problem here is he said it does. And I says, no. You literally went through a week of telling me top and bottom, and now you're sitting there telling me this, and now I'm telling you what the problem is, and you don't even want to hear it. And he goes, well, I told you to, I'm like, he goes, well, that can mean this. And I says, no. You specifically told me this, and it literally turned into a debate. I literally argued with him to the point I just said, get the fuck away from me, and I walked out. I says, don't even try to teach, don't even pull this shit with me. So one of the problems students have is this word manipulation needs to fucking go. It's absolutely abysmal, and the math teacher, regardless if it's a teaching technique, it's bullshit. Because you cannot drill into somebody's head, top is top and bottom is bottom, especially when dealing with fractions, and then tell the person to remove stuff from around and then say, well, all these definitions mean different things. Bullshit. If that's the case, you're never going to get the concept because you don't know when those terms apply. And this is one of the things that they tell you, rules matter. No, there is no friggin' rule for that. I don't care what you say. And unless math wants to say the word around, you have to define what these words are before you even go into anything. Because if not, most people roll over and accept that. I refuse to accept that if you're going to tell me math is an absolute. I will never accept that. I don't give a shit what any of it is. As far as I'm concerned, you say top and top is bottom, then guess what? Everything in math from start to finish, from top is bottom and bottom is, that's just it. So the point is if people are going to argue, if math people and people, whatever, want to use these terms, do what I'm about to do. You literally have to set it up So you show them that what they're telling you, they can't do. So let me get into a wider array of a more complex issue that deals with the area and square footage, because I got into an argument with my landlord about this. And again, no matter how I tried bringing this up in my head, was that I was literally bringing concepts that there would be no possible way you could argue with, and he would still argue because he didn't want to hear it. So my point is, asking for help is pointless, because the community has it set in their brain for some weird screwed up reason, and they don't even want to have any room for debate, because you can't, no. That's bullshit. Because I am literally debating these points with actual facts that they're saying, and then they're saying, well, I didn't show you that. So these specific wording issues can lead into other even bigger problems, such as this one. It got to the point where I was taught by so many different tutors and so many different things, and being told to just go with it. I didn't know how to go with it. And so it got to the point where they were saying, oh, you just don't want to learn. And all that did was piss me off even further, and I'm yelling, because that's what basically people are told. You're told you're lazy, you don't want to learn, which is complete bullshit. What's going on is they're telling you one thing, telling you it's an absolute, and then telling you to forget about it, while telling you to keep the base principles. It can't be done. It's not possible. So this is why people say math doesn't follow logic. This has nothing to do with logic. This has to do with math in itself working a very specific way to say what people are telling you to do, math prevents from being done. Math literally, the basics past division, literally prevent most algebra equations from even being written. They do. They do. You can't, the math itself, just math, this doesn't even have to do with me. Math itself prevents itself from being done. It can't be done. So you can't tell somebody this is how it works. Just forget about it. We can do it this way. What? No. And so without even taking that into consideration, no student that has this problem, once they hit this barrier, is ever going to be able to do math, period. There's no help for you at all. And I'm not saying that to be negative. My point is, if you understand where this is your problem and you can get around that barrier, great, please do it. But this is the barrier you run into. This is the problem. So let me get into a few additional things on how I argue these points by changing configurations of what the numbers are being represented with. So check this out. I got into a heated debate with my landlord about square footage and area. And one of the questions I was posed with, which I find very interesting, is that they go, well, it's work for math. I says, no. The problem isn't people are making the math work. What happens here is I've actually dissected this backwards. Now, this is going a little off the rails, but this is to get my point across. If you start with a solution and then you build your question around the solution, the question will always match the solution if that's the way you do it, because you can literally reverse engineer an answer and then work a question around the answer, so the question will always fit. And that's the argument that I use when people say, well, how does it work? Because if you actually take a look at what I'm about to say, it'll fuck with you. Okay, so we're now going to get into a few different very specific wording and very specific things that, again, these are basic math fundamentals. This is what math says has to be present, must be there. You can't use imaginary numbers. You can't make things up. It has to be present in order for you to do all the equations and everything else. And this is where these fucking word manipulations with these, word problems come in that I fucking can't stand. This is another reason why people have a problem with word problems. Okay, so what you have here is, I'll take area. Okay? If you want to find an area, okay, math says in order for you to do a problem, all of the I don't say, how do I put this? Whether the numbers or what's represented in the problem has to be present before you can do it. So in other words, 2 blank equals 4. 2 plus blank equals 4. That's not a math problem. That's an equation where the problem is saying what is the missing number. But without the missing number, you can't do the problem because it means nothing. So this is a case of where people try to take and manipulate one system of math and apply it where it doesn't actually apply. Let me explain. Okay, because this is going to get really complex, but you'll see where I'm going with this. Okay, so if you have a 3 foot by 2 foot, and you want to find the area, the base principle tells you to multiply 2 times 3. Okay, let me explain why that's wrong. Because if that's a multiplication problem, and the way to do this problem is to assume that whatever half is showing is the exact same as the opposite half. So for example, if you have a top that's 2 feet, that means, and there's no written bottom, that means the bottom is 2 feet as well because it'll make a square. The problem I have with this, and the problem that mathematics says, you only have 2 parts of the equation. Doesn't matter whether it's an imaginary thing or not. Unless all of the pieces are present, you only work with what you have because that's what math tells you. And this is where people start getting into, well, this is just the way it's done. Bullshit. You just told me that these 2 are the only things present in the problem. Well, that's the only you need. No, you need all 4 sides. If 2 of the sides are imaginary, you don't have 2 of the sides because now you're getting into math just says you can't use imaginary numbers that don't exist. And then they'll tell you, well, it does exist because that's just the way. No. There's a difference between saying, here is a setup for the problem, and then saying, do the problem itself. Oh, yeah, okay, so all right, let me rephrase that. Okay, so what they're trying to do is get the square, they're trying to get the area. The area is known as the inside of the square. Okay, it's the inside of a square. Or I'm using this as a square. So it's the area is inside. So if you want to find out what the inside is, you basically multiply the sides together. That's what the equation tells you. The problem is that there's only 2 sides. There are not 4. Even though the example says, oh, if there's 2 sides, you just assume that the other 2 sides are there and then make it a multiplication problem, you've just literally caused 6 different problems within that problem for the person trying to do it. Let me explain. I'll break this down as simply as I can because this gets a little complex to follow. Okay, if the top is 2 feet and the side is 3 feet, math tells you you cannot get 4 sides off of that equation. Not that you can't get it, but the base fundamentals say you can only work with what is present. If 2 of the walls are imaginary, then no, those are not present because math says you can't work with imaginary numbers. You have to have all the pieces present. And this is why people start saying, well, you got to know the rules. This is just, no. You can't combine a rule with a fundamental and then say the fundamental doesn't apply here because the rule says it. No. Well, that's an exception. If you actually look up the word exception, that's not a thing. Exception literally means the opposite of what's being said. So math cannot have exceptions in it. That's not a thing. And I will argue that point with professors. It's not. There is no such thing as as an exception. No such thing. It's either there or it's not. Because again, this reverts back to math is an absolute. There is no exception on an absolute, even when trying to do a problem. You're told math has to have all the pieces up front. So if you only have one side of something and then another side of something, and then you're told to get the area, the problem's unsolvable. No matter what any teacher tried, well, you just do the other side. No, because now the teachers are ignoring what they just told you. How the hell could you get a side of something when the math says in order to get the inside of something, all 4 sides of this must be present? All 4 sides are not present. Oh, there's an exception. You just assume they are. No, math says you have to have the absolute numbers in order to get these things. So now you start coming up with an even bigger problem because this is a multiplication problem. Why does it make it a multiplication problem? Like, how is that? Why is that a multiplication problem? Have you ever, nobody can seem to answer why that's a multiplication problem. But the reason it's a multiplication problem is because two of the sides are missing. Multiplication is nothing but a fancy way of adding. That's all it is. It's literally addition. It's just a different way to add. That's all it is. Now, if you take that into consideration, how the problem is set up, it becomes a different math equation. Let me explain. If all four sides are present, it's no longer a multiplication problem. Go figure that one out. I'll let what I just said sink in. So, if two of the sides are missing, it's a multiplication problem. Somehow, but if all the four sides are missing, if all the four sides are there, it's not a multiplication problem, it's addition. Which is bullshit because you were just told to find the area, it's a multiplication problem. So that means 2 up top, 2 on the bottom, 3 on the side, and 3 on the side. It's 2 times 3 times 2 times 2, times 3, and that's it. Now, this brings into an even bigger problem when you're dealing with powered numbers. Because powered numbers are set up, let's say, 3 to the third power. That's basically 3 timesing itself. 3 times 3 times 3. I just set up the same exact problem. However, the answer is freaking different because you get a different problem. 3 squared is 3 times 3 times 3. It's actually not that, even though that's written that way. And it's the same problem with when you have a side of something that, if you have all four sides and it's a multiplication problem, it would be 2 times 3 times 2 times 3. But when it's 3 squared, the answer is 27. Because it's 3 times 3, which is 9, and then 9 times 3, which is 20, and that becomes 27. What? That doesn't make any sense whatsoever. And so when you're dealing with the square analogy, you have 2 times 3, which is 6, but if you have all four numbers, you add the thing doesn't this whole thing doesn't make any sense whatsoever. So at this point, if somebody's trying to learn this, they don't know what the hell is going on. They don't, because now you screwed them. And what will happen is, if you go and tell somebody, if you literally try to bring up anything I just brought up, not only will they get confused, they were like, "How did you even arrive at this?" And no matter what you tell them, they don't want to listen. And so, everybody, if I bring this up I've actually posted this on a math forum, and everybody says, "Oh, I'm doing it wrong." I says, "No, I'm not doing it wrong. You're telling me I'm doing it wrong because you are the ones not following the rules. I'm literally putting these rules that math itself puts in place, and you're telling me that math is wrong." This is where the conflict comes in. A bunch of people are literally telling you, even though the rules of math say it cannot be done, to do it. No. And this is where I will argue with any math professor on the face of this planet. I will literally debate these points with them. So let me bring in another factor here that it's kind of like really screwy. Now that whole thing was a little out of whack, but it was to prove a point. If you got confused, that was supposed to confuse you. And the reason why I set that up that way is so it was next to impossible to follow, because that's literally what you're being told to do. You are being told to follow something that cannot be followed. That logic literally makes no sense, what I just said, at all. However, what I just said is exactly what math says to do. It's same thing. However, when people are saying, you get the area, no, because if you're going to tell me the area is a multiplication problem, but then you're telling me it's not a multiplication because of how it is, but it's still an area problem, stop telling me this shit. It's either a multiplication problem or it's not. There is no in between. Oh, no, it's either a multiplication problem or it's not. Now, if it's a multiplication problem because you just told me 2 times 3, then guess what? I'm going to draw the other two squares because math says I have to have all of the, I'm going to draw the other two sides so I have a perfect square, or I have a square. Not a square, sorry. It's not a square if it's odd. It's a rectangle. My bad. So, because two sides are longer than the other. But anyway, if you're going to tell me one side times one side, then you've literally just said that's a multiplication problem. So, math, I'm going to use the rules of math. Math says I have to have all the sides present. So I'm just going to draw the other two and then write whatever number is on the top, on the bottom, and then I'm going to write whatever number was on the side, on the side. If you notice, I said top and bottom and side to side. So I'm still using that same principle. Okay, now it's a multiplication problem. I'm going to multiply 2 times 3 times 2 times 3. And they'll say, nope, that's wrong. They'll tell me that's wrong. And then I will argue, well, this is the same thing as, 3 to the third power. Nope, that's wrong too. Now you're being told what they just told you is wrong, despite them telling you do it, and then you're following the basics on rules of math that they're telling you that that's how you have to do this because math says it, but it's an absolute, but you can't do this because the sides are missing. Oh, you just have to imagine it. What? Now you don't know what the hell is going on. That's literally what these problems are doing. And until the system wants to accept that they're fucking with people doing this, and this stuff can't work because math tells you it can't work, then there's going to be a problem. And so let me bring in what I actually argue a point on with my landlord when it came to area. Okay, so this will piss off math people. And I actually figured out this system to show that they cannot manipulate numbers because another problem is the counting manipulation that's done, which I'll get into that in a minute. And so you first have to set it up. So, well, I don't want to say set it up, but let me explain. When you're dealing with math and you're dealing with numbers, you can use anything to represent those numbers because the amount is the issue, not what you're representing. So if I put 2 coffee mugs or, 2 face cloths or, whatever, it's still 2 because I'm representing the number 2. We just write 2 because it's easier and we visualize it. But you can break it down into anything. So you have 2, 2. What I do to prove that it cannot be multiplication when you're doing an area is I change the numbers into dollar bills. Okay? If you have let me explain. If you have a 4 by 4 square, 4, 4, 4, and 4, and you need to find the area, okay? And you only have 2 sides, they're going to tell you to multiply 4 times 4. Okay, that's fine. That's 16. Now let me explain why I use dollar bills. If you have 4 on one side, 4 on another, and you multiply that 4, are you going to get 16 or are you only going to have $8 bills? I don't give a shit who you are. You're not going to multiply money out of nothing. It doesn't work. The only possible way you can actually get a $16 amount is by adding the 2 other sides together and then putting 4 on that side and 4 on that side. You cannot get 16 unless you actually have 16 to represent. I don't give a shit what the multiplication says because, again, if you only have 2 sides and it's a multiplication problem and you can represent the numbers with any amount, with anything you choose, 2 sides on a 4 using 4 $1 bills is only going to equate 8. It is not going to get, you're not going to magically have $16. It's not going to happen. So without the other 2 pieces of the sides, the right side, the bottom, you are never going to get $16. And that is why I argue, I don't care who it is, unless you wind up with $16 by multiplying 4 by 4, and you will get $8, then there is no person on the face of this planet that's going to tell me that's a multiplication problem. I don't care who you are. The reason why I turned it into $1 bills is because you can't manipulate that. And so it shows where the error actually is in the problem. You can theoretically do it as a multiplication if you're not using actual things to represent. But to say you're going to, no. No, because you don't have 16 $1 bills by placing 8 on the table. You're going to have 8 no matter what you do. It's an addition problem, not a multiplication problem. So this is where they start not wanting to hear about it. You're just dumb. Despite what I just what I said, I took every base principle that was used. It was, and this is their arguments. I took every base principle that they did and I applied it, and it was wrong. Despite they're the ones who came up with that. But putting that aside, I used what math says is allowed. Not what some idiot says, not what some professor says, not what some scholar would. No, I used the basic foundations that math says is allowed. Now this gets into counting manipulation because he started trying to use a different diagram to describe the same thing. And I says, no, you still have this amount, because now what happens is this counting manipulation has to do with using numbers in one place and then taking those same numbers again and using them in a different place, despite math says once you use something in a place, you can't change it around. And people say, oh, that's an exception. No, there is no such thing as an exception because math is an absolute. Okay, so here's the thing. Instead of taking a 4x4 area, I'll use a 3x2 area. Now, you have 3 on top and 2 on the bottom. Now, what happens here is the counting manipulation is the corner piece. There is no corner piece. This side is made up of 2 things, and this side is made up of 3. If you take one of the pieces from the top and transfer it to the side, you still have 2 and 3. But now, the top only has 2 and the side has 3. What the math these people like to do is take the 3 from the top, count it, and then they also take the one they just counted on top and then apply it to the side. 1, 2, 3. What? No. And that's the counting manipulation they use. They literally will take a section that they've already counted, that's here, and move it to here. The problem I have with that is, if you write 1, 2, 3 on a paper, and then you write 1, 2 down, if you scratch the 3 off of here, and then you transfer the 3 to the bottom of the second line, the 3 is no longer on top. So that count is now undone. Oh no, it's still there. We use it as an imaginary. No. Because math is an absolute. You cannot use the same number in 2 different places and have this first number that you used it in remain the same. Here is the example that I use with this. I'm going to give you $1.50, and I'm going to tell you to go to 2 different stores. Okay? I want you to spend that $1.50 in both stores. Point being is that if I give you $1.50 and you go to the first store and spend it, you cannot go into the store, say, I need that $1 back, keep the product, and go to a different store and use that same $1. It doesn't apply. That's why I use money, because money can't be manipulated. And despite the facts on what I just stated, you're still told, no, the exception to the rule doesn't. No, it doesn't. And I will argue these points with anybody. I will argue them, because nobody is going to tell me you're going to start making up imaginary numbers. You're going to start using more than one number in different places, despite you're not allowed to do it because math is an absolute. And the other thing that I started doing is, if I ask somebody to count to 6, this has to do with sequential counting now. Sequential counting, if you ask anybody, because now I'm gonna word it out so you understand how fucked up this is. Sequential counting from 1 to 6. Sorry, 1 to 5. Let me get that out of the way. So, if I were to have you count from 1 to 5, there is no possible way you can get a 6th number in there without adding a 6th number. It's not possible. However, in this equation, 3 on top and 2 on the bottom, or on the side, they somehow get 6. How? That's not possible, because if you draw 5 dots, you're going to have 5 dots no matter how you rearrange them on the paper. If you have 5 $1 bills, you're going to have 5 $1 bills no matter how you arrange them on the paper. There's no way around that. So what happens here is that sequential counting, if you have 5, you go 1, 2, 3, 4, 5. However, the equation that they're using counts 1 twice. 1, 1, 2, 3, 4, 5. That's how they get 6 numbers out of that. That is not counting. Counting in it. Now, here's why I bring up the fundamentals in the rulings for how things work prevent that count type from being done no matter what. Anybody in their right mind will never count 1, 1, 2, 3, 4, 5. They just won't do it. Because that's not a count. That's not a count. Everybody agrees with that. So if that's the case, how the hell come math can get away with it? It literally makes no sense. And so despite you telling people counting doesn't work like that, they somehow will argue it does. In this particular way, no. And so you don't have 6 numbers. No matter how you just don't. You still have 5 numbers. Counting one of those numbers twice is not going to give you 6. I don't care what it is. But that's how you're being told that equation works. No. You're not going to tell me you can use a number in one place in another place. That's like the store. You can't use the same dollar in 2 different stores and keep the product. It doesn't work. Once you move something or do something, it no longer remains the original way to do it. It's not even a placeholder at this point. It just doesn't work. And so the thing here that the issue that people are having is exactly what I just said. This whole system in itself is fucked. It literally prevents itself from being done. And the people who cannot do math or have a problem, a very severe problem trying to understand it, is because they are actually following the mathematical rulings. They are literally applying what the math says at the points they're saying it. And the reason that they can't go beyond it is because no matter what anybody says about the exceptions, the basic rules of math stop them from doing something, because the basic rules of math say what that is. That's not possible. It's just not possible. So even if people want to, again, even if I know I'm hammering this into the ground, but even if people want to argue that there's some exception, the base rules of math say it can't be done. It's not even you. It's the rules of math. Again, math's being absolute. Counting doesn't work like 1, 1, 2. It never has. Nobody is ever going to count like that, because that's not how counting works, especially sequentially. It doesn't work that way. Again, if you draw 5 things on you're not going to have 16 $1 bills if you're multiplying the sides. It's just not going to happen. And so, it's like, it's absolutely ridiculous that math has been, this is a mess. It's a complete mess, and it literally goes against its own principles. So, if, man, how do I even put this? So, as I said, you are not the problem. If you are having a problem doing math, that is because you're smart. That's something you'll never hear anybody say. Not being able to do math means it's simply because you follow rules. That's it. That's the whole reasoning why people. Now, some people can get past certain barriers because they roll over and accept things. Like, okay, I have a really bad problem with math. For some screwed up reason, I got a 97 in my math class. I don't know what the fuck I'm doing. I wound up getting percents on my test, which was the only thing I had problems with. And the only reason I was able to do the percents is because I hit a trick that I knew. That's it. So what happens here, if people get stuck, they start trying to find tricks, which is not the same thing as actually doing math. So even though you pass it, somebody's like, oh, you passed your class. You really didn't pass the class, because you manipulated the math system. But that doesn't teach you anything. That's why people can't do percents, because most of the time they use a trick, like move the decimal point. What the fuck does that even mean? It's like, how do you figure this out? But the trick becomes overly complex when you start dealing with numbers that the trick, you were never taught how to do the trick. So here's another problem with math. Another argument I got into with my tutor and a few tutors is that when they told me to do something, they were trying to get me to understand basic principle on when to use and apply certain principles, which is not possible. Because math is so many, people are just applying whatever the hell they feel like, whenever the hell they feel like, and making some random solution to something, and they're not explaining how it is. So when somebody, if you watch a math teacher say, well, all right, I'm going to start by dividing by 6. Where did they get 6 from? Why not 25? Like, nobody's explaining what they're doing. Like, so I said, seriously, why are you choosing 6? What told you to choose 6? And he didn't even get the question I was asking. It was absolutely ridiculous. So that, now I'm sitting there trying to figure out where he got 6 from. It's actually preventing me from listening to the rest of it, so now I don't know what the hell's going on. And it's like, when he was saying, when he did something, he gave me, I did something, I followed whatever he did, and then I came up with something. And then he gives me another problem. Now, he purposely gave me the second problem, knowing I was going to get stuck at a point. And so what wound up happening was, I discovered when I did this, the reason I stalled is because the principle for that specific point in time in the problem was never taught to me. So what happens here is this opens the door for, if you have 6 problems that all use the same base system, but the number is different, you have to teach that person all the ways to solve all 6 of those problems. Because one base fundamental does not apply to all of them, even if mathematics people say they do. They don't. Because if they do, you wouldn't be getting caught up in certain things. So I used these base principles that I was told, and then when I hit a certain point, he couldn't figure out why I was getting stuck. I said, that is because you did not show me this principle. And he was saying he did, meaning the overall aspect, but the in-between stuff, when I hit the start of it and to that point, there's a missing piece. The outer perimeter is one thing. He goes, well, I did show you this. I'm like, no, you didn't. I said, you showed it to me with this problem. He goes, well, this problem is the same as that. I says, no, these are different numbers, which means the principle is different. And so he's like, no, it's the same. And I knew what he was saying, but I'm like, listen, you taught me a principle using the number 4. You didn't show me how do you apply that principle to the number 6. It's a different problem. It may use the same fundamentals, but as soon as you change the number, it becomes a different problem. The principle on overall may be the same, but you will get stuck because the principle that you're taught works with the number 4, but it doesn't work with the number 6, even though they tell you it does, because they're trying to apply the base principle rather than the actual number itself. And that is a problem, because instead of getting help for him, instead of him actually taking apart what he did and saw why I was having a problem, it's just, I don't want to learn. Really? I literally laid it out. These are different numbers. How are you going to tell me what you showed me with 4 works with 6? And he goes, well, this, and this. I says, I did this here, and I cannot carry this. I says, this is impossible to carry over. He goes, well, you just do this. I'm like, no, that doesn't work. I said, that works with 4. And it's like, it was just going in a circle. And I says, I am not going to accept that you showed me this principle, because as long as you're using the number 4, I'm going to argue that you showed me this is not, So they can say whatever they want. That's when you get told you're not listening, you don't want to learn, you're just being stubborn on purpose. It's freaking ridiculous. It's absolutely ridiculous. So this, again, falls into asking for help is pointless, because the people don't want to listen. The people that are teaching you don't want to listen to the actual problem. Or if they do, they brush it off like, well, no. Just no. And that is why there's no room for debate. And that is why the wording matters. And that is why, asking for help is pointless, because nobody wants to see the problem. But then again, it backs up into my point on what I said earlier. Let me pull these back up on the screen. Where it's irrelevant to practice. you will never be able to practice at this point, because what the hell are you practicing? You can practice what you were taught, but that's only going to get you so far, because you will be stuck being able to get this problem completed. It's impossible. And so this again reverts back to the very principles and fundamentals of math. The basis of math alone, just in itself, tell you that all these high-end problems cannot be done. So again, you have to look at, well, how are people doing it? That is because they reverse engineered. They wrote the problem around the solution. They didn't write the problem and they came up with a solution. They wrote the problem backwards, so the problem will fit the solution because it was written backwards. They reverse engineered it. That's the best description I can give. So, again, I'm not trying to harp on this to be negative. This is just the problem. In every single person, no matter who you are, if you have a problem with math, this is the reason why. It's because you are following rules. Now, that's not to say, how do you just ignore these rules? You really can't. And so, this has nothing to do with you having the willingness to learn. This has nothing to do with you not wanting to learn. This is just, fuck you. That's what this is. You've literally been blocked off from being able to do this because the rules of math are ingrained in your head. And that's not your fault. That's because that's how math works. So if you are following math rules, you will never be able to do anything beyond division. And if you do, that means you're not following the math rules, which is nothing wrong with it. Don't get me wrong. But I'm just saying, the reason why some people do this is because they just, oh yeah, here's an exception. They don't even know what the fuck they're doing. If you are literally doing anything beyond division, you are not following the math rules, because the math rules say what you're doing can't be done. And that's it. It is literally that simple. And so once you understand where your problem is, only you can get around that. You literally either have to roll over and accept it, or you're never going to be able to do math. It's simple as that. I am never going to be able to be taught, because as long as math says one thing, I am going to go by what math says, not what some teacher says, not what some asshole made up some exception to the rule or any of this. I will go by mathematics, and I will stand by that, because if you're going to teach me math, you are not going to tell me you are better than math. You're just not. And that has nothing to do with the willingness to learn. But you're not going to tell me this is how math works and then say forget about it, but it doesn't work here, and then tell me you're still following the rules of math. You're just not. And that's basically it. So I will open this up for a Q&A right now. But I hope I was able to at least help people understand where the problem is, because I think now that you're looking at it, you start to understand exactly what the issue is. Like, this makes perfect sense. Now you understand why you're having a problem. And it's not you. And this is why math is not hard or easy. It's just there. The issue stems from the rules. Did you get yourself blocked in that position? And the wording. I have a problem with the wording in math simply because I don't give a shit. It's like, don't tell me top bottom and then freaking change the word to mean top and bottom when you use it around. That's fuck off. It's just not going to happen. I'll actually be told now, it's like, well, yeah, with that attitude, no wonder you don't want to learn. It's like, and then they tell you don't want to learn. This is like arguing with somebody in a video game. It's like, I just said that, and then after everything you say, they say something really stupid, like everything you just said went out the freaking window. So any math person watching this video, at the end of this, they'll tell you, oh, you just don't want to learn. After everything I just explained, after everything I just talked about, they'll say, oh, you just don't want to learn. You're being stubborn. Well, get rid of the negative attitude. That's not going to... What does any of that have to do with the rules of math say this is how it has to be done, and you are trying to do something that these rules state you are not even allowed to be doing? And then try to argue, well, they can. No, math says you can't. So it's like math in itself prevents math from being done. And that's why some people will never be able to do math. It's not. And again, if you can get by that roadblock, all the power to you. But just remember, and this isn't. I'm not talking down to you. If you are going above division, you're not following the math rules. You're just not. So, like I said, I'll leave this open for QA. There's a lot to take in, I know. I've pretty much been up all night. I'm like, ugh. I think somebody's trying to write something. Getting really messed up right now. My head's in a fog. I'm like, ugh. I'm zombietized. Hey, if all goes well, I'll be doing another Urban Explore, so within the next, 2 weeks or something. So keep an eye on the 360 Investigations channel. That's if all goes well. So I've had to postpone this thing 3 times so far. Oh yeah, and one other thing. I don't know how to correct this. I don't know how to correct, how do you tell somebody to forget rules that you just stated that are needed in order for this stuff to work? It's like, how do you correct that? So even if you tell a teacher, it's not going to, and they do get it, it's pointless. Okay. I mean, if you have any, I'll like I said, I'm leaving the comments open. So if you actually go back and watch any of this stuff, it's a little hard to go over. But like I said, I went into some really warped stuff, but it all boils down to the same thing. I mean, you have the rules of math telling you that there were math problems that just the rules state no, just no, and so. This is why I said asking for help is basically pointless, because even you can show this to a teacher and they could, and say for sake of conversation, they actually agree with what I'm saying. How do you can't help somebody that's already had this embedded into their head? It's just the way it is. Like, how do you get somebody to, like, even though you understand how to do the math, it's like you can't do it. It's just like there's a block. So the real question is how are the people doing it ignoring what the base fundamentals were and thinking they're actually, I don't understand. Like, do you trick your brain? I don't get this. I really don't get it. Man, I am so tired right now. Like, ugh. I gotta go to bed soon. I'm like, ugh. And with that, I think I'm gonna end this stream. If nobody had any more questions, so yeah, like I said, I mean, take this video, show it to people that you think are having problems with math, and it'll, like I said, I'll explain it, because this is the information I'm giving people is just help, because this is like some relief that somebody actually understands where the problem is, and they go over it. It's just like what I find interesting is that people that, professors and stuff, they will literally try to counter these arguments, and I will not hear them out, because I just won't. Because again, it's like you have math telling you something that you're trying to do cannot be done, and then you're saying, well, just listen to me. No, you listen to what the math says, and then I'll listen to you. So I don't know. It's really too bad that this is the state of the system, the way this stuff works. It's really bad. It's freaking terrible. So, yeah. Yeah, exactly. But the one, like I said, the one common problem that everybody has with math is the same thing. The people who can't do math or have a problem are the ones following the math rules because they're literally doing what math says to do, and then they're being told to ignore it, and they can't. Your head is already stuck into these are the rules. Yeah, but the thing here is, like I said, once you get past basic division, you are no longer following the rules of math. People who follow rules are all the people who can't do math. All of them. Because they're applying what they're taught. They're not just taught, but they're applying what math itself says to do. So this is not even a question of what a teacher says or what a professor says or anything. This has to do with math says 1 + 1 is 2, and you can't have an addition problem without an addition symbol. When you give somebody a problem that doesn't have an addition symbol and tell them it's adding, they're not going to be able to do it. And they can sit here and tell you whether it's an exception to the rule. Your mind is, math already told you it's not possible to do without an addition symbol. So how do you get through that barrier? That's, like I said, how do you get through that? Because you're in a conflict. It's like, how do you add something together without the component to add? It's like literally impossible. It doesn't work. Math says, no, you can't do this because it requires an addition symbol. That's it, So more tutoring isn't going to help you. If these base rules are in your head, there's no amount of tutoring that's ever going to be able to help you. You will not, because the block itself, what prevents you from going further, are the rules you are applying. That's the actual block. Has nothing to do with the freaking problem. Because if you notice, there are some people who go past certain points and then they get stuck. Some people can't do certain multiplication, but they can do some algebra problems. But then they get stuck because the same principle applies. Algebra is nothing but, you can't do fractions without knowing multiplication. And algebra is basically all fractions. Fractions are nothing but multiplication. So if you have the base rules of multiplication, it's going to cause a conflict for something further in multiplication, whether it's an equation or anything else. Well, no, this isn't even abstract thinking. This is, the rules say one thing and you're being told to ignore them. But without the rules, you can't do what you're being told to do. It's literally a conflict. So that's it. Because now let's say you forget about the rules and then you go ahead and do it. Now your mind's wondering how the hell you arrived at the answer. Like, how did you even do this when you don't even have the right tools to do it? It just doesn't make any sense. That's like driving a car without gas. A car requires gas. It's a component of the car. You have to use it. Not a component of the car, but it's something that has to be used. Then you're being told to drive the car without gas. What? That doesn't make sense. Oh, it can be driven without gas. Yeah, if you put some other fuel in it. But it's like, no. Just no. So anyway, listen, I'm getting really tired. I'm like repeating myself now. It's getting ridiculous. And so I just want to say thanks for, thanks for tuning into the stream. Oh my God, I can't even talk. Thanks for tuning in with the stream. I will talk to you at some point. Steel Gamer signing off.